Hi, ninth standard, heat chapter. Numerical problems we can discuss in this video. These numerical problems are easy, but once if you are able to understand what is the suitable formula to be followed here to work out this. To talk about the problem number 2, we want to understand the day-to-day life activity. Once if you are going to take bath using hot water, if the water is boiled and if it is with high temperature, we cannot use that to take bath. So that we want to reduce the temperature of the water. In order to do so, we are adding cold water into the hot water. So this cold water which is added by you is reducing the temperature of the hot water, and in a suitable temperature we are using that water to take bath. So the heat lost by the hot water is equal to the heat gained by the cold water. Based on this principle, if we go for the problem number 2, that is easy for you to understand. So you can now listen this problem, how to work it out. Using the board we can discuss this. Okay, thank you. Here is the numerical problem number 2 of heat chapter in the board. What could be the final temperature of a mixture of 100 grams of water at 90 degrees C and 600 grams of water at 20 degrees C? So the specific heat capacity of water is given here, but it is not given in your book. It is generally a constant, so that we can take this in account. Now here 600 grams of water at 20 degrees Celsius is mixed with 100 grams of water which is at 90 degrees Celsius. When these two are mixing, this 100 grams of water is with high temperature, whereas the 600 grams of water is with low temperature. So usually the heat will be absorbed from the high temperature to low temperature. So in that case, this 100 grams of water will lose its heat energy and the temperature falls. Whereas this 600 grams of water may gain this heat energy which is given by the 100 grams of water, and the temperature of this 600 grams of water will be rising. So the question is asked, what could be the final temperature of the mixture? Let us go to list out the info given in the problem. Let us consider this 100 grams of water is M1. M1 is equal to mass of the water is equal to 100 grams. So this 100 grams can be converted into kilogram. So once we convert this 100 grams into kilogram, is 0.1 kilogram. Then the temperature difference, delta T. So the initial temperature of this 100 grams of water should be taken as Ti. And the final temperature we don't know, that we want to find out using this problem. So that the 90 minus final temperature Tf. So 90 is the initial temperature given in the problem itself. So 90 minus Tf. And the specific heat capacity C, the value is written here with the unit. And the formula is to be used here to calculate the heat lost or heat given out by the 100 grams of water is equal to M into C into delta T. Now when we go for the another information given for the 600 grams of water, this mass of the 600 mass equal to M2 is equal to 600 grams, and when you convert that into kilogram, that is 0.6 kilogram. Delta T here, this is heat gained, so that the final temperature is to be taken and the initial temperature can be subtracted. Now this Tf minus 20. So the initial temperature of the 600 grams of water is 20, so that it is given here. So the delta T value is here. C is common to both the sides, so that this is given as 4200 with unit. And the same formula for heat gaining also to be used, mass into this specific heat capacity of water and into delta T. Using these two, we know that the heat lost is equal to heat gained. By applying all the values in these two formulas, we can finally reach to the answer. Okay. Let us continue this problem using the formula. Now you know that heat lost is equal to heat gained. In the problem, the formula is to be used here for heat lost and heat gained to calculate mass into the specific heat capacity of water and also delta T, the temperature difference. So here also the mass into specific heat capacity of water and the temperature difference. So when we go for this calculation, the mass of this water which is losing its heat energy is 0.1 kilogram, and specific heat capacity of water is 4200, and into the delta T value 90 is the initial temperature of the 100 grams of water. I mean this one 0.1 kilogram of water. So 90 minus TF. TF means final temperature, and that is equal to, see, heat gained 0.6 kilogram, that is 600 grams of water, and here also the specific heat capacity is 4200, and into delta T. Delta T is heat gained, so that the final temperature minus 20 degree. 20 degree is the initial temperature of the 0.6 kilogram of water. And when you go for the calculation, this 4200 is common both the sides, so they are cancelled, and the remaining 0.1 into 90 minus TF, 90 minus final temperature, and here 0.6 into, this is cancelled, so final temperature minus 20. When you multiply this 0.1 and 99, that is equal to, then 0.1 into TF, 0.1 TF, that is equal to 0.6 into TF, that is 0.6 TF. TF means final temperature, and 0.6 into this 20, that gives you 12, minus 12. And now you exchange these details sidewise. See here, bring this 0.6 TF this side. See, 0.1 TF plus 0.6 TF is equal to, you bring this 9 this side, that is 9 plus 12. So now 0.7, when you total sum of this, 0.7 TF is equal to 9 plus 12, 21. If 0.7 TF is equal to 21, what will be the value of TF? You can bring this 0.7 this side, and that becomes a division. So TF is equal to 21 by 0.7. When you divide this, you will get the number 30. So that 30 is the final temperature, so that can be used here with the unit of degree Celsius. So final temperature of the mixture is 30 degrees Celsius. That is what using this heat lost is equal to heat gain formula, we are calculating this problem number 2. Go through this video repeatedly and refer your book. You can understand this easily, and we will meet in the next problem soon. Thank you.